Okay, now that all like the intro-y stuff is out of the way, let's talk a little bit about Java versus Python. It's going to be very high level, and remember, like I was saying, the point of this course is not to learn Java. You're going to, by virtue of just using Java, you're going to learn it. And I am going to like show you Java-y stuff along the way, don't get me wrong, but you're not going to get a full description of explanation of everything Java. Don't expect that, it's not going to happen, okay? So like we saw last time, here's hello world in Python, and here it is in Java. And we did take a moment to talk about how, well, you know, it looks like 1, 2, 3, 4, 5, the Python's 1 line of code, the Java's 5 lines of code. All right, well, we immediately know 2 of those lines are just closed braces, so whatever. And we also learned how, well, everything in Java has to be in a class, so you only, like if I wanted to print out hello world twice, the Python would take 2 lines of code, and it would take 1 more line of code, and the Java one would take 1 more line of code. Like we don't need all of that stuff. It just happens to need to be in a class that has to be in a main function, okay? And other than that, things that we notice that are different is, okay, this like public class, but we talked about that class is class public. We already were aware of this idea of private and public from before, but now we have keywords for them. Double quotes are required for strings in Java. Semicolons are there. We don't use white space. We use braces to indicate like what is contained. But of course, we use the white space as well, but it's not technically required. But now to get a little bit more of the things about Java versus Python. And one thing I will say too, and I said this like last time and the time before, something I really want to make sure is clear is, as you're going through this, you're gonna feel like, man, Java's a lot more work. Python's so much more like easy. It's more relaxed, it's more easy. Yeah, I wouldn't fault you for thinking that, but you're kind of wrong. That easiness definitely makes it a lot harder to work with as things grow. It's great for quick and dirty stuff, but as you're building more and more complex functions, unless you're very careful, it's a lot easier to make mistakes in Python than it is in Java, at least certain types of mistakes. Other types of mistakes, same difference. Like, for example, if I want to make an integer in Python, okay, I can just create a variable and int, assign it 5. Boom, there we go. A float, it's 5.5. A string, it's the string 5. Great, I could just do that. I didn't need anything extra. In Java, well, of course, everything I write, let's say it's in the main. It doesn't need to be in a main, but it's ultimately got to be run through a main. More on this later. Like a function call to a function call to a function call, like if it was in there, whatever, but it would have come from main at some point. We got our class, we got our main. But if I wanted to make an integer, I would have to say int and int equals 5, semicolon. This right here, I'll talk about this more in a moment, but this right here is doing 2 things. This line of code, it's declaring and assigning a variable. You only need to specify the type when declaring the variable. I'll more on this in a moment. But I would need to make, if I want a variable for a float, I say double a float 5.5. We use the word double to mean float. And the reason we use the word double to mean float is, to be clear, there is a float in Java. You could say float, it'll work just fine. But double means double precision float. Long story short, remember how in Python, like 0.2 plus 0.1 was 0.300000001 or some weird thing like that? It gives it more bits, so you will have less floating point precision issues. If we want a string is that there. Notice that the type S starts with an uppercase. Who can guess what that means? It's a class. It's an object. The type is an object, where these ones aren't. Int, double, char for character. They're primitive types. They're different than objects. In Java or in Python, that line was blurry deliberately. In Java, there's a little bit more of an explicit difference. Interestingly enough, there is an object version of int, double, and character, and so on. But more on this later. They are important for reasons. Yeah? If I wanted to make like a double that's an object, it's uppercase D, double. int, it's uppercase I, integer, uppercase C, character. And they come up because we'll learn about this as we go, but I'll just tell you now. If this makes sense to you, great. If it doesn't, we'll get there. There are certain, remember how like in Python, like if you didn't write that equals, it gave you one for free. And remember how like if you didn't write that like repr, it gave you one for free, right? But the fact is that thing was an object and you got it for free. Everything that's an object has an equivalent of like a repr, for example, in Java. Whether you write it or not, it does, but primitive types don't. So if there are things that you want to work on objects, and we know if the language enforces all objects to implement certain things, then I know that I have those things, where with the primitive types I don't. More on this as we go. It's not something that you need to completely understand at this point at all. So don't worry too much, but that is an explanation. Char, mind the fact that it's single quotes for a single character. This is the character 5, which is technically different than the string 5, which is different than the integer 5, which is different than the float 5, or the double 5. Any questions about what we're seeing there? So there are a few main differences. In Java, we must declare a variable with its type. In Python just kind of figured it out for us, which is fine for a lot of the stuff that we've done, but this is going to become a bit of an issue, and it already was an issue for you in the past. Remember that example of like that add function I wrote where you give it two variables, or two values that happen to be strings? You give it a 1 and a 1 and you get back 11? What's up with that? That's because you gave it strings. The string 1 plus the string 1 is 11. But your function, you intended it to take integers. That type of mistake can't happen in Java because you have to be explicit about this type. More on this as we go. We use the word double to be floating point number. Like I said, technically we could use float, but double is very common. A float takes up 4 bytes and a double takes up 8 bytes, double the amount. It lets us have more precision in our numbers. We don't need to be too worried about things like bytes and bits in this class. I'm just explaining it to you. We use double quotes for strings. Single quotes are used for characters. This does mean that we have a new type though, char. Technically this kind of was in Python, but it wasn't, but it was, whatever. That doesn't mean, that does mean we have a new type. So like we could have a character, the letter B, which is the letter B, which is different than the string B. The letter B is a primitive type. A string is a collection of letters, whether it's one letter, no letters, or a billion letters. But the point is a character will only ever be one letter. Or it could be an empty string, which is technically a character. It's a whole thing. And we use // for comments, unlike Python's number sign or hash or whatever you want to call it. And we end each line with a semicolon. Like each of these statements are ended in a semicolon. So not all lines are ended in semicolons. Like this didn't end in a semicolon, this didn't end in a semicolon, but these like statements of like do this, do this, do this, do this, do this, they all end in a semicolon. Things like loops wouldn't have the semicolon at the end of the declaration line of the loop. Yeah?
What's the point of characters then? Because wouldn't a string just be better usually?
Well, a character, it really depends on the programming language. It's actually really interesting. Like, a character takes up less space, right? So there's a benefit there. Although technically Java, I'm pretty sure it's like, don't quote me on this. I might have the numbers and the precision. Like I won't have the nuance to this quite right. But like the Java compiler, let's hit pause on this and I'm going to come right back. When you write your code, when you write computer code, who is it for? It's for humans. Computer code is for humans. Machine code is for computers. When you compile your code, you take your code that is written for humans and turn it into machine code. There's more steps for Java, but let's skip those. And that's actually what gets run on your computer hardware, okay? Don't get fooled, for lack of a better term, into premature optimization, where you work really hard to make your code lightweight, small, take up less space, more efficient and everything. Because the compiler, the thing that turns your code into what the computer runs, will do a lot of that for you, and chances are it's going to be better at it than you are. If you've got an algorithm that's n squared versus linear, it's not going to do that for you. But it will do a lot of that optimization for you. Okay. For example, in Java, if you're like, I want to represent something as a character, so I can use the string, but I can use less space and it would be faster for the computer and use less resources to use an individual character type instead of a full string, which would be true. But Java is smart enough, the compiler will look at like short strings and just pretend to treat them like characters and they'll be fast anyways. So it's about the right tool for the job. Yes, a string is more powerful, but technically, there's always a trade-off at the end of the day. Now the compilers do a lot of magic for us, but purely speaking, and the fact is, strings are effectively arrays of characters. So the characters must exist to have strings. So that's also, like, the fact that we have strings, like, necessarily we must have characters that are used to build the strings. Long story short. Think of it as like a string is just like a list of characters, except you don't represent it as a list. You just kind of put them next to each other. Cool? Happy, sad, yeah. Okay. For the sake of brevity from now on, though, I'm going to not include the class or the main stuff, right? It would be there if you were just whipping this into Java, but I'm not going to write it in my code snippets because it just takes up too much space, okay? All right. Another thing, a warning. In Python, one could change the value stored in a variable to something of a different type. In Java, we can't do that, and that is a good thing. If one what I mean is, if I had made a variable called otherInt and set it to 5, and then immediately said otherInt equals totally not 5, but it's a string, it's a different type. Python's fine with that. Java, if I tried to do that, this code wouldn't even compile. Not only would it not run, Java wouldn't even turn it into something that it could think about running. Okay? So if I wouldn't fault you for thinking but I like that flexibility. Well, you're wrong. You don't want that flexibility. Why do you want that flexibility? You might think you want it, you don't. Be more explicit and clear about everything you're doing. Be very intentional. It forces you to be more intentional. This won't work because the types aren't there. This is like a good example of this type of coding. It forces you to code very defensively. The language itself forces you to code things defensively, which is a fancy way of saying it really hedges against certain types of mistakes that you could make in Python, but you couldn't in Java. Yeah?
Could I turn the variable into a different integer?
Yes, you could turn it into a different integer, though. As long as the type is the same, it's fine. It's type safe. So declaring and assigning variables. In the example above, with Java, I declared and assigned the variables on the same line. This is entirely normal. In general, I'm a big proponent of have one line of code do one thing. This is one of the big exceptions I make because it's so common and there's really little room for confusion. There's a difference between declaring and assigning a variable. So in Python, you didn't need to explicitly declare a variable. It got created automatically whenever you did an assignment. But in Java, you must declare it. So for example, when I said anotherInt equals 11, Python goes okay, they want a variable called anotherInt and it's 11. Great. In Java, did I just say Java? That's Python. In Java, that first line is an example of declaring. I'm saying, hey, make an integer variable called anotherInt. On the second line, I'm saying, okay, anotherInt, you're set to 11. Notice I don't need to specify the type anymore. I only need to specify the type when it's being created, it's being declared. Every other time I use it, I don't need to specify the type. That would be annoying. So this is the declaration, this is the assignment, and then I'm printing it out. However, it is so common, like I showed you here, it is so common to do the declaring and assigning on one line the first time you use it. This is very normal. So don't freak out if you see that. Okay, however, in Java, one could declare on a single line like this, like int anotherInt equals 11. That's fine. The first time you assign it, you would have to declare it and specify the type. Yeah? No, you can't.
You can kill a variable with the same name.
I don't think you can. And if you could, don't.
Yes, obviously.
If there's a way to do it, I don't know it, and there's a good reason for that. Yeah, don't do that. So reusing variables. So here we go. A is 5, print out A plus 2, great. B is now A plus 7, print it out. B equals B plus 1, okay, print it out. B plus equals 1, whatever. I'm just doing some weird stuff in Python. What is this doing? I don't know, it doesn't matter, I'm just playing around. How would I do this in Java? Well, I'm doing my declaring and assigning on one line. That's fine. So int A equals 5. But now A exists. After line 1, A exists. I don't need to specify the type anymore. So print out A plus 2, whatever, it's fine. B doesn't exist, so int B equals A plus 7, okay? So that should be 5 plus 7, was a 12, print it out. And now here, I'm reusing B. I'm taking the value of B, adding 1 to it, and putting it into B. I don't need to specify the type. I only needed to specify the type the first time. It knows B exists, and it knows it's an integer. And then down here as well, great. Cool. Questions? Anything? Thoughts, concerns, comments? 1, 2. Yeah. You can. Yep. And in Java, you can also use another shorthand, a short shorthand, plus plus. That just means add 1. Okay? Now, actually, I'm curious what's going to happen. Check this out. So A equals 0. Oops, no, what am I doing? Okay, when I hit run, what should you see? 0 and then 0. Better. 0 and 0. Now, to your question, can you use plus equals 1? So if I go down here and I say, okay, A plus equals, let's do like 4 or something. Why not, right? Yeah, I'm feeling wild today. So what should I see? 0 and then A plus equals 4. Oh, that's 4. Okay, great, cool. Any questions about this? Now, obviously plus equals 1 also works. Let's run that. There is another shorthand, plus plus. Okay? Where plus equals works where it basically means like A equals A plus whatever's over here. If I do plus plus, I don't specify an operand. Like there's no value specified here. Actually, I didn't put that there, like that. There. Whenever you do plus plus, that means increment, add 1. Minus minus, guess what that means? Subtract 1, obviously. But you want to see why? Okay, watch. There is a difference, though, between like A plus plus. Okay, we know what's going to happen. Here, actually here. Yeah. I showed you what A plus plus does, but there is a difference between plus plus A and A plus plus. There is a difference. First of all, let me show you that this does in fact work. 1 and 1, great. But there is a difference. Now, this is more of a food for thought thing. My recommendation I haven't explained it yet. I'm going to explain it. But my recommendation is if you code things in a way that I recommend you to code, this particular issue would never come up. But the A plus plus versus the plus plus A, I can put that here. When I hit run, take a moment, look at this code. What do you expect to see? Just don't answer, don't say it out loud, just in your head, think about it. And I want you to be honest. When I hit run, raise your hand if that's what you expected. I'm not asking you if it makes sense. I'm asking you, is that what you expected? One person expected that. Okay. Now let me do this. Is that what you expected? Okay, so depending on where you put the plus plus, A plus plus means increment A, but it'll be the last thing that happens on that line of code. Plus plus A means increment A, but do it before you do anything else on this line of code. So it sees this line, I'm going to print it out, plus plus A. Add 1 to A, print it out. Here, this means print out A, add it, go to the next line. It gives you a way to specify. The first example I showed you, without knowing this, it kind of is ambiguous because that line of code, printing it out and incrementing, there was 2 operations. Like written like this line of code has 2 steps in it. Which one's first? If you don't know, you don't know. So that type of syntax allows us to specify. It gives us control. However, I see your hand, just one sec. However, I strongly recommend that you only ever have 1 line of code, do 1 thing at a time. Okay? To eliminate any potential issue, if you want to increment it, A++, fine, there, done, right? Make it so each line of code does 1 thing. As soon as you start having 1 line of code with all this crap going on, you're not impressing anyone, you're just pissing them off. You have a question?
Not the question or observation, but I mean, I feel like it's the same thing as the print len, right? Because it prints first, then it goes to the second line.
Well, but then there's print with no line, right? You can do that, and then we'll see 1 and 1. We'll see 11. That really just depends. Yeah.
What about in the parentheses of the print line, the shorthand A plus equal 1? Does it work the same like A plus plus?
Let's find out. So before, when it was plus plus, we saw 0, 1. So here we see 1 and 1. Well, actually, so looks like this. We'll just do it first. Now incrementing, you might be like, okay, it's a shorthand for shorthand. But incrementing is so common that we'd like to have a shorthand for it. Just adding 1. It's counting. Very, very common. And the way we write it has some meaning. Now in other languages, it's funny. In other languages, like if this was C or C++, the way these operate, the way these work, really do depend on the compiler. So like Java, there's like 1 set standard compiler. If you have a different programming languages, you might have different compilers for those programming languages. Different tools for turning your code into machine language. And depending on how that translation tool is implemented, it might act a little differently. So there might be some like non-standard stuff that you observe. This turned into a big thing in my like 2nd year university when I was taking a class on C where there was like this giant flame war about, and it came down to what compiler we're using. It was a whole thing. Long story short, I just showed you this for the sake, there is a difference, but eliminate any potential issue by just don't have 1 line of code do multiple things, right? Oh, do I need plus plus A or A plus plus? Just don't have them, eliminate the need for having to ask yourself that question by don't need to ask that question by just have each line of code do 1 thing at a time. Yeah. What about in loops?
I feel like it would matter more.
It actually, loops are funny, and we'll get back to that later. But loops are funny. So there is technically an advantage computationally to plus plus I, although I'm going to imagine the compiler will eliminate any actual advantage it has, but more on that later. It's about like how much RAM it takes up. It's a whole thing. You could literally go watch a 20-minute YouTube video describing why plus plus I versus I plus plus is better in a loop, although it doesn't actually matter because the compiler deals with it anyways. This is where like people nerd so hard out about this stuff, right? Where like, don't get me wrong, it could be a lot of fun, I'm not saying don't enjoy it, but like let's not get too far into the weeds right now. Cool. All right. Okay, yes. So just a warning or a note though, I just showed you an example of reusing variables. In practice, like if we have a counting variable, like a loop counter or something, yeah, we're reusing variables all the time. In general though, we often don't really reuse variables very often because it's not usually very helpful unless it's like a counter, like where a variable specifically designed to keep track of a running total or something, right? But like if we're doing the temperature in Celsius, if I have a variable called temperature in Celsius and it stores the value like 72, it's hot, okay, 72. And then later you need to do another calculation for mass. You're not going to reuse the variable called temperature in Celsius. That doesn't make any sense. So like, yeah, we reuse variables, but you probably do that a lot less frequently than you think, right? Because the variables, I mean, the whole point of the variable, first of all, creating a variable is cheap, right? It's not 1970 anymore, and you need to be worried about RAM and all that, and the compilers are good enough to free up all the space and deal with all that type of crap for you with memory management. So you don't need to be too worried. Variables are a great way to not only store variable data, but give a name to your data, right? If I see a variable called temperature in Celsius, what does that mean? It's probably the temperature in Celsius, right? Remember, the names of these variables are very important. Constants, you might remember constants from Python. They are variables, and you usually set them like at the top of your code, and they're set by a programmer, and they are not to change through execution of the program. I mean, the programmer can change the value of the constant, but once I hit run, the value of that constant shouldn't change, right? Like, think back to Python. If I had a constant at the top of my code called sales tax, and it was set to 15%, and the government changes tax to like 14%, then I could just go change that line at the top of my code, and if I'm using sales tax throughout my code, great. I don't have to go through and change all the 0.15s to 0.14s. Great. All right, easy peasy. Why is this good? Well, you know, variables, and I change it in one place, it's changed everywhere. Second, if I'm looking at this code and I don't know what's going on, maybe it wasn't written very well, and I just see a bunch of 0.15s, I might be going like, what the hell's that? If I see a variable called sales tax, oh, I know what that is. But a big part of the whole constant thing is I set it before I hit run, but once I hit run, the code's not going to say like sales tax equals sales tax plus 0.1. Like the code isn't going to modify that value. That's against the rules. The programmer can change the value, but the code shouldn't change the value. It's constant through execution, right? That was the spirit of them. But in Python, some jerk came along, they could change the value of the constant in the code. Python won't stop you. You would just be committing a pretty big Python sin, right? Like you don't do that. You just leave it alone. But you could, but you don't. And we specify that they're constants by being all uppercase. So there's like a convention among programmers. So I know, and if I'm a good faith programmer, I see this variable, it's all I know it's a constant, I don't touch it. In Java, I can actually say, okay, well, yeah. In Java, I can actually use a keyword called final, to say, to modify, to actually like this keyword final says, this is a constant. So not only do I know it, like we follow the same convention, sales tax, the programmer sees this, they know it's sales tax, but unlike Python, if the code did try to modify this, Java won't even run. It won't even compile. Because the keyword final was there. It's a constant. I'll show you. Final int sum int. It won't enforce that you follow the convention for naming, of course. Let's call it 0. And if I say sum int plus equals 1, look, it's just like, no. You said it was a final. You can't change it. So Java actually allows you, the programmer, to specify that this variable is in fact a constant final, and it can't be changed. So now there's no guessing. There's no like, I hope the other programmers don't screw with it. There is, you can't. You can't screw with it. That's a good thing. So if I go to hit run, it probably won't even compile. Yep, can't do it. You can't. It's a final. You can't do it. Any questions about finals? That's pretty handy. We're going to be using constants a lot. They're handy. They're good. If you can make something constant, you do. We like that. Because if things are constant, they're immutable. We can't change them. And remember, we like immutable things. We like that. Yeah?
Okay, so I'm seeing in the error code like the 7, which I assume means line 7, but like, where's the 9?
Probably like character 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So it's like literally saying line 7, character 9. That's the start of your issue. Yeah. Don't get too excited about Java errors being that helpful. Yeah. It's pretty good, but don't get too excited. Okay. Other questions, thoughts, concerns, comments, anything? Happy, sad? Awesome. All right. Remember, it's possible to change a constant's value before runtime. A lot of people always, but you just change, the programmer, remember, I'm God in my code. I can do whatever I want to my code, but anything like I've specified, like I can't make my code do anything. No, that's like, that would be breaking the rule because I already specified that this is final. Okay? Cool. But, so like I can go here and be like 10, and that's fine. I can change it, but the code itself can't modify it. That's what I mean by constant. All right, arrays. Java, not at least in the same way as Python, Java does not come with lists. Out of the box, it does, you just have to like import them. And they are there, don't get me wrong. But in Python, lists are just there. You load up Python, you can make a list, boom, you're good to go, right? In Java, no. You'd have to import stuff and do all this funny setup. Python makes lists really easy to use. Lists are fantastic. In Java, we don't have lists as easy and ready to use. But we do have something called arrays, which are easy and ready to use, but they're far less capable than lists out of the box, at least. Now, in this course, we are going to be working towards building things like lists. Stacks, queues, bags, lists, trees. We're working towards building these things. I could go to Java and be like, import array list. And I've got a list. In the same way, like, would be very similar to what you're used to in Python. And students always invariably ask, and I'm going to say this again later in the course. Students invariably ask, well, why would I build my own list when I can go import it? Because you're taking a course on how to build data structures. And if your point is, well, if I'm taking a course on how to build data structures, why don't I just load up the existing data structures? If you're taking a course on how to build a car, and you show up and you're like, why don't I just go buy a car? Fine, do that. Don't take a course on how to build a car. We're building these data structures. And we're going to build them with what we start with. And what we start with would be something like very simple, like an array. So yeah, Java does not have lists as ready to go as Python does. They're not provided as like a language primitive. Java does, however, have arrays, which are similar-ish. They have the same general idea, but there's a number of constraints that we have with them. Though we very quickly address these constraints in clever ways. First, they both, lists and arrays, store data in a sequential, linear way. You can index them in the same way you do lists, right? In a list, the thing at index 7 comes before the thing at index 8. Same with arrays. But, unlike lists, arrays have a fixed size. When I make an array, I make it with a specific size. If I want an array of size 100, I make an array of size 100. And if you say, well, what if I want to put 98 things in there? I go, great, you have plenty of room. What if you want to put 102 things in there? You can't. They're size 100, you can't do it. But what if I want to? You can't. There's not enough. There's like 50 seats in this room. What if I want to sit 60 people in here? I can't. There's no 60 seats. And arrays have far fewer built-in functions or methods or whatever you want to call them. Okay? So here's an example, though, of creating and using a list in Python. I'm creating a list in Python of literals. I'm hard coding these values. This list could have been loaded from a file or something too, right? But I put some literals in here. Remember, when I say literals, I mean like this is literally the number 10. Like I'm writing in the values, okay? So here's a list, 1, 2, 3, 4. How big is that list? How many things are in it? It's not a trick question. Perfect. If I print out the list at index 1, what do I see? 11. Good. If I say a list at index 1 is 21 and I print it out, what do I see? Great. Here would be doing the exact same thing in Java. Now the types matter, but I'm making an array, but it's an integer array. And I know it's an array because I use these square brackets. That specifies I'm making an integer array. And to hard code literals into an array, I would use these braces. Now, we don't do this very often, but this is how you would do that, right? Like, what I mean is we don't go hard code array values very often. We do in some cases, we will, but this is not that common. So I've got an empty, or not an empty array, I'm declaring an array with the values 10, 11, 12, 13. How big is that array? 4. Great. How do you know? Well, because I put 4 things in it. It's got 4 things in it. Now with a list, I could have said like a list out of pen 55, and it would just add it. If I were to try to do something like append to this array 55, Java, that's not a thing. That's not something I can ask Java to do with an array. So I could say print out an array at index 1. What do you think would get printed out? Java's cool. So what do you think gets printed out? 11. Yeah, that's right. You understand. If I change it to 21 and I print it out, great, there we go. It's 11. Now notice arrays are mutable, right? Like lists were mutable. I can go to a value here and change the value at index 1. It's mutable, right? Remember how like with strings I couldn't in Python? Same thing in Java. You can't, strings are immutable. But more on that later. Cool. Any questions about what we're seeing here with arrays? The syntax is different, but the idea is the same so far. Yeah.
Like you say, you have to specify a size for an array. Like if I do an empty one, like I did here in rhetorics, what does that mean? Like does it have 0 size or 1?
So you never made an array. You declared a variable for an array, but you never made an array. So it's like saying like I have an int like int a, but if I don't assign it to anything, well, what value does it have? Well, I didn't make an integer. I just have a variable ready for an integer. It's a funny nuance that will become far more clear as we go because that idea is something that comes up a lot in this course.
And in Python, you can make an empty, like...
Yeah, you can make an empty array in Java too. Okay. But all you've done is you've declared the variable. Yeah. So, with the exception of the type and syntax, they look the same. We specify the type in Java int array. It's an int and it's an array. Great. We use squiggle braces instead of brackets. Fine. One difference is that Java can't contain mixed types like in Python. If I have an integer array, I can only have integers in there or ints in there. There is kind of a couple of ways around this, but in general, no, you don't. One major difference, though, is that the above example, that array is always size 4. I can append to that list and make that list bigger. With Java, the array is size 4 and it will always be size 4, and I can't do anything about it. There are easy solutions to that, but I can't do anything about it. Remember how, I'll give you a hint towards the easy solution. Remember how in Python, if you want to modify the value of a string, if you want to change the value of a character in a string, you can't do it in Python, right? You just can't do it. But we kind of had a trick to do it, right? What do? You make a new one based on the old one with the change you want. It's the same thing here. We're going to make a new array that's bigger based on the old array. But spoilers, we'll see more of that shortly. Yeah, fixed size. That means you can't start with an empty array and just grow it indefinitely. At least not easily. So here's what I mean by growing an array. So let's say in Python, I wanted to make a list with the values 0 through 999 in it. How could I do that? Well, here's one way I can do it. There's a lot of ways I can do it. Now, I'm not going to go open up Python. Like, first of all, let's agree that, like, okay, pretend this is Python. My list equals, I want 0 through 99. 0, 1, 2, 3, 4, 5. Obviously, I'm not doing that. That's ridiculous. So I'm going to, like, automate that with the loop. So the loop for I range 1,000. So we know that's going to run 1,000 times, 0 through 999, right? And I go to that list. It starts empty, and I append to it. Okay, it has a 0 in it. And I append to it. Now it's 0, 1. Append to it, 0, 1, 2. Append to it, 0, 1, 2, 3, and so on. Right? Happy, sad, questions? If you have a question about this, ask now. In Java, we can't do that. But, I mean, here's a quick way around that. You create an array. So, to be clear, this is the declaration. This is like saying, okay, I want to like have a variable for an integer array. And then I have to create the integer array. That's this side. I'm saying new int array. Whenever we're creating something that is an object, with the exception of strings, strings are funny. With the exception of strings, we need this new keyword. Okay? We didn't need this in Python, that's fine. But we need a new keyword. So go create a new array of size 1,000. But it's like size 1,000, but there's like nothing meaningful in it yet. So I've created an array with 1,000 empty seats. Then what I'm going to do is I'm going to iterate over that array and go to each seat and put something in it. Where before in Python I just kept appending to that array and the gray size grew, or the list size grew. Here I start with an array of size 1,000 and I go and I assign each value. Simple solution to this growing array issue of like, well, what if I want values like that, right? Yeah.
If I didn't put anything in those actual values in the array in order to like try to find a certain value for that array,
Yep.
like what exactly would I get?
So in Java, by default, it will start with whatever like a default value is for whatever the type is. If you have something that's like an array of objects, that would be null. This is not objects, this is integers. Integer is a primitive type, the default value is a 0. So if I go, let me show you, right? If I say int array, my array equals, oops, 100, because why not? And I say print, no, let's do, I'm gonna show you a for loop. I know it's spoilers, but length. No, not I. We want my array at I. There. We're just going to see 100 zeros. Boop. Right? So it has a default value. This is Java. Other programming languages work a little bit differently. And I will take the time to go over this because it is very interesting and it is always kind of nice to learn a little bit about the differences of languages. But we need to take a moment to break down the parts. This side of code means somewhere in memory, if I draw over here, can you see over there pretty well? Okay. Somewhere in memory, pretend this whiteboard is memory. It's sequential, right? So we could pretend like, okay, and we've got like, okay, all these different memory addresses, right? Right? And then somewhere in memory, I'm going to create, okay, my array. My A for my array. And Java knows, okay, that chunk of memory, what's stored in there is not an integer, but it is a reference to, remember references with lists, same thing. Everything that is an object in Java will be referenced by a reference. Will be like stored as a reference. Primitive types will be stored in there. So if I had like my I for an integer and I said equals 7, great, well, 7 goes in there. But the declaration here for anything that's a reference, this sets this chunk of RAM aside as a reference to something that is going to be like the beginning of an array. The right-hand side, the computer goes somewhere in your RAM and goes, oh, okay, right here. Let's say this is like size 100, like in my example there. So what's stored in here is that. Okay? So that's why, like, your question about, like, how come I didn't need to specify size. This thing, the reference doesn't care how big it is. This thing, the actual array, cares how big it is. The reference, all it needs to know is that it's referencing something of this type. But it doesn't really care anything about the value of that type. It just knows what it's referencing, the type of what it's referencing. So here, that's the difference there. Now, in Java, so this is just a chunk of RAM. In Java, Java's nice and goes, okay, these are all like whatever. There's nothing in there, it's empty, whatever, 0. But in other languages, and this does depend on the compiler, but let's say it's 1985 and we've got C. And C goes and gets, oh, they want an array of size 100. Okay, let's just set aside this chunk of RAM. But the way RAM works is think of RAM as like a giant list. And maybe I'm storing information in arbitrary indices in that list, right? And when I don't need that information anymore, the computer doesn't go in there and wipe it out. It just is like, okay, that chunk that I don't need anymore, it's eligible for an overwrite, okay? So, like, I just don't need, like, old painters a long time ago, they wouldn't get new canvas, they would just paint over old canvas, right? So if there was a canvas where it's like, here's an ugly picture, I'm not gonna, like, get rid of it. I'm not gonna waste my time getting rid of it. We could just overwrite it when we need another canvas. I can just paint over it, okay? That's the same idea. So here, when I go and set this aside, I don't know what's in there. Maybe there's a happy face, a sad face, we got a Christmas tree up here. Whatever's in that RAM is there. And so I can go, if this was another language like C, and this was a while ago, again, it depends on the compiler, and I create an empty array and I say, okay, tell me what's in that array. You're going to get a bunch of garbage. Whatever the zeros and ones in there are will get displayed. Now, because the types of the data, because everything in here is zeros and ones, okay? Not really, it's low voltages and high voltages, but zeros and ones. If something is of type an integer, and I have zeros and ones, I'm going to decode that thing as an integer. If it's actually a character, I'll decode it as a character. It all depends on the type. The zeros and ones is an encoding of information, and its meaning depends on the decoding of that information. Do I decode those zeros and ones as an integer or as a character? And we did do this last semester. Does anyone remember that ASCII stuff I showed you? Maybe? Where 97 is actually the letter A.
Oh, yes.
It's the same thing. The bit pattern for 97 and the bit pattern for the letter A is the same. The way the computer knows how to represent it to you, a human, is based on the type, which is kind of neat. So that was someone asked a question about you. Did that help? It's cool. Yeah.
How does Python do it?
How does Python do it? Python is going to do it more like Java, but Python you usually aren't dealing with arrays. You're going to deal with lists, which are a level of abstraction above this. That this is a hard comparison to really make. But we're going to learn about like lists and those like the ADTs, the abstract data types and collections that we're going to be talking about. Python's going to work more like what we're about to learn in this course, which is pretty cool, I think, right? But yeah, cool. Yeah, let's see. Okay, there we go. So mine line 2 showing how to make an empty, yeah, okay. Okay, mine line 5, the for loop, more on this later. This is a for loop in Java. Create an integer I, starting at 0. While I is less than the array.length, one of the few things that arrays knows. Arrays are very stupid. They don't have very much functionality or data associated with them. But one of the things arrays do know is their length. You can ask an array its length. An array is an object in Java. Based on this syntax, what do you think length is? Can anyone? This is a bit of a reach. But do you remember how we learned, like, does that look like a method to you? No, it looks like a field or a property. Depending on the language, we call them different things. So this is like a data field, like an attribute associated with this thing. So the arrays actually know how big they are, which is pretty cool. And then I++, so this is a for loop. We're going to talk more about it in a little bit. For where do we start? 0, when do we end? Or basically this is like the condition. Well, I is less than the array length. That would be like for I in range, length of 1,000 or something, right? I plus plus. What do we do every time we finish iterate, like one run of the loop, increment I by 1? That would be like, if I were to say, like, remember how like we could do like range to like 100 comma 2, and that would mean count by 2s or something, right? Or no, that would be the third one. Where to start, where to end, what do I count by? We could do this in Python too, just the syntax is weird. Python, like all the other like common popular languages are all like this. Python's the weird one actually. But we'll end here because we're out of time. Any last questions? Yeah.
What did you say, like dot length was?
It's like actually I can't remember in Java what we call it, a property, a field. It's like a variable but associated with the instance. Like what's your first name and what's your first name? You both have a first name, but their values are different. It's not a function, it's not a method. It is a variable or a property. Yeah. It is, it's an object. It is.